I welcome all the students. Uh, Today's topic is mass spectrometry. Mass spectrometry, as you know, what is the name of the subject? It's an analytical, it's an instrumentation technique. So, likewise, other instrumentation technique which we have already learned. It is also one of the type of the analytical technique, right? Analytical technique means that we are going to do an analysis to detect some compounds or elements or metals in a unknown sample and also quantify its quantity, right? So mass spectrometry is also a spectroscopic technique. Now, as the name suggests, mass spectrometry. So here the mass has a very big role in identifying the elements in an unknown sample. So let's begin our presentation. Let's begin the presentation. First of all, the definition and the principle. What we understand with the mass spectrometry. So mass spectrometry, okay. So mass spectrometry, what is that? Mass spectrometry is the most accurate method for determining the molecular mass of compound. As I told you here, the mass has a important role in determining or analyzing any compound, right? So determining the molecular mass of compound and its elemental composition. It is also called as the positive ion or the line structure. Or in other words, we can also define the mass spectrometry as it is an analytical chemistry technique. Analytical chemistry technique means here we are doing the analysis that helps identify the amount and type of chemicals present, means qualitative as well as the quantitative technique of presence of a compound in a sample by determining the mass to charge ratio. Just one thing keep in mind, this is the important thing which we will identify in the this mass spectrum. There is a mass to charge ratio. What is the principle? What is the principle? The principle is that it consists of ionizing chemical compounds to generate charged molecules or molecular fragments and measurement of their mass to charge ratio by using the one of the variety of technique. See, I just clear your concept. What happened in this technique? Unlike other spectroscopic technique which we have already learned, in the previous technique which we have learned, that the analysis is all depend upon the absorption light and the emission of light. Here, this analytical technique is all not depend upon any kind of absorption of light or any kind of emission of light. Here, the analysis is all depend upon the charge to mass ratio. Whose charge? Sorry, mass to charge ratio. Whose mass to charge ratio? Whose analysis going to done? जिसकी हमको analysis कर रहे हैं, उसकी हमको यहाँ पे mass to charge ratio देखना है, right? कैसे देखेंगे? तो firstly the sample will be converted into the fragments, or we can say the fragments में convert करेंगे, or we can say into the ionizing fragments में convert करेंगे, and after the conversion into the fragments or the charge species, its mass to charge ratio will be identified. Okay, I just show you the picture. Just wait. I just see. You can see here, this is the diagrammatically representation, so you can better understand. This is the sample in which we are going to estimate the compound or metal or any kind of element into the sample. So what we will do, we will introduce this sample into the ionizer, and what this ionizer do? This ionizer will split this sample into the different ionizing fragments, means that fragments will have the positive charge as well as the negative charge. But in majority of cases, the fragment will have the positive charge. So what will happen? This neutral sample will convert into the ionizing species or the ionizing fragments, right? Now, this ionizing fragments or the ionizing species will move to the mass analyzer. Now, this mass analyzer, according to the mass upon charge of the ionizing species, it will separate the different fragments with the help of the magnetic or the electric field. Now, whatever the separation done in the mass analyzer, the result or the signal will go to the detector, and the detector will plot a spectra between the m upon E or the mass upon charge to the relative abundance. What is mean by relative abundance? Relative abundance means that masses species, how much quantity of that masses species are present in the sample. Okay, again come to the our topic. So the MS principle consists of ionizing the chemical compounds. Okay, how we are analyzing the chemical compound? We are ionizing the chemical compounds by putting inside the ionizer to generate the charge molecules or molecule fragments. Generally, the samples are converted into the charged species by bombarding it with the fast moving electrons. Okay, so we will discuss later on, but here just want to just understand the sample is converted into the ionizing chemical compounds by putting into the ionizer, and after the formation of these molecular fragments, its measurement means the mass to charge ratio. Just like the mass to charge ratio means it's m by z. Okay, we designate this mass upon charge ratio as the mass upon m upon z. M upon z means mass upon charge which is present on the surface of the fragment. Okay, moving ahead. So at the measure of the mass to charge by using one of the variety of techniques. There are different techniques, different analyzing technique by which we analyze the mass to charge ratio. So just one thing keep in mind, that in the mass spectrometry, two things we analyze. Number one, mass to charge ratio, and second, its relative abundance. Relative abundance means how much quantity of that masses are present in the sample. Moving ahead, introduction. What we do? Mass spectrometry uses a high energy electrons to break a molecule into fragments. That I've already told you, that the high energy electrons are bombarded with the sample, and the sample are converted into the fragments. Okay. And the sample is converted into the fragments, and that fragments will have the charge. That's why it is called the charge species. Okay, it does not involve the absorption or emission of light. There is no absorption or emission of light, unlike the other spectroscopic techniques that we have already learned, like the ultraviolet, IR, other techniques, right? The masses of the fragments after the formation of the fragments. Next, what happened? The ions are separated in the mass spectrum. Sorry, the masses of the fragments and their relative abundance reveal the information about the structure of the molecule. Now, after these fragments are reaching to the mass analyzer will determine the mass upon charge and their relative abundance on the basis of the mass upon charge ratio as well as its relative abundance in the sample. We will reveal the information about the structure of the molecule, right? Structure of the molecule. Okay, like just take an example. Okay, just take an example of methanol. Here you can see this is the neutral molecule, and when this neutral molecule is bombarded, when it goes into the ionizer, it is bombarded with the fast moving electrons, and it will split into a different charging fragments. Like it can split like this. it can split like this, or even it can split like this. So what will happen? This charge fragments will go to the mass analyzer, and in the mass analyzer, the mass analyzer will determine the mass upon charge ratio of that fragments as well as its abundance, and on the basis of the mass upon charge ratio as well as its abundance, we will get the information about the structure of the structure of the compound present in the sample. Okay. Now coming to the introduction. Okay, so analysis of the fragments provide information about, when we analyze the fragment, we will get the information about the molecular weight as well as the structure. Okay, next. The ions separated in the mass spectrometer according to the mass upon charge ratio and are detected in proportion to their abundance. Okay, and on the basis of the mass upon charge ratio and their abundance, we will create a mass spectrum of the molecule. We will get the mass spectrum of that molecule. Okay. Now it displays the result. How we will get the result? It displays the result in the form of a plot of ion abundance versus mass to charge ratio. I'll show you the one spectrum of a molecule. See, this is the typical mass spectrum of the aspirin. See, you can see here, this is the, what is the mass upon charge ratio of the aspirin? This is 120, and you can see here, this is the 100% relative intensity of the mass upon relative intensity of the aspirin present in the sample, and in this way you can say that it contains, so this relative, this is the, this peak, this sharp peak determines the, this sharp peaks indicate the relative abundance of the molecule in the sample, right? This is the long sharp peak. This gives the relative abundance of the molecule in the sample. So this is the typical mass spectrum. You can see on the x-axis we take the mass upon m upon z, mass upon charge, and on the y-axis we take the relative intensity, right? And this is the sharp peak we get for the aspirin, and this sharp peak represent the relative abundance of the molecule in the sample. Okay. Next. So this is the schematic of mass spectrometry. First is the ionizer, next is the mass to charge ratio analyzer, and finally it's a detector. I just show you in the form of one flow diagram also. See here. See here. I have already show you ionizer, mass analyzer, and the detector. Moving ahead. See, this is the typical mass spectrometer in laboratory. This is the fusion, or it is a combination of liquid chromatography or liquid chromatography mass spectrometer and the mass spectrometer. See, mass spectrometer can become with the liquid chromatograph also. This is the industrial or the laboratory mass spectrometer. Typical. This is the next typical mass spectrum. What is the properties of the mass spectrum? See, it is characterized by sharp and narrow peaks. This is the sharp and narrow peaks, right? Sharp means it should have the resolution that we can easily identify the peak of a particular molecule. Okay. Next. So it is characterized by sharp and narrow peaks. The x-axis position indicates the m upon z that I have already told you, ratio of a given ion, and the height of a peak indicates the relative abundance of an ion. I had already told you this height indicates the relative abundance of a molecule in a sample, and this x-axis shows the mass upon charge of that molecule. Now Now with this m upon z and the relative abundance, we will get the idea about the structure of the molecule which is present in the sample. Next, MS operation. This MSP stands for mass spectrometry. See, nearly all mass spectrometer, one thing, the very important thing, that the working in the mass spectrometer is done in the high vacuum condition, right? There must be a present of a high vacuum condition. What is the high vacuum condition? Less than 10 to the power minus 5 torr. Okay, so nearly all mass spectrometers need to operate under high vacuum condition with the pressure less than 10 to the power minus 5 torr, with the only exception of there are two kinds of spectrometer which is have the exception of this pressure. It can have the more than 10 to the power minus 5 or even less 10 to the power minus 5 pressure. The example are ion trap mass spectrometer as well as the ion mobility mass spectrometer. These are the two mass spectrometer in which it does not follow the vacuum pressure less than 10 to the power minus 5 torr. But in majority of mass spectrometer, the pressure should be less than the 10 to the power minus 5 torr, right? So it should be the working must be in the vacuum condition. Next, if you are new, if you do not how to operate the mass spectrometer, so never turn on the mass spectrometer without knowing the chamber pressure. The chamber pressure plays a very big role, very important role in running the mass spectrometer. If the chamber pressure, as I've told you, if it is not up to the level, it is not less than 10 to minus 5 torr, you will not get the proper result and it may affect the instrument also. So without knowing the chamber pressure, do not turn on the mass spectrometer. Okay. Next, obtaining a mass spectrometer. How we will obtain the mass spectrometer? Conversion of neutral molecule. I have, as I told you, give you the example of methanol, right? So conversion of a neutral molecule into a charged molecule. How you will convert to a charged molecule? By putting into the ionizer. In the ionizer, the neutral molecule will bombard it with the fast moving electron, and that fast moving electron will convert the neutral molecule into the charged molecular species or the charged fragments, preferably to a positively charged molecule. Now, separation of the positively charged fragments formed based on their masses. I am again reminding that here the mass have the important role in identifying the sample. Okay, so whatever the positive charge fragments form based on their masses will be separated by using the electrical or magnetic field. Now what will happen? Once the sample is converted to the fragment, there will be a lots of molecules will be present in the sample. So according to their masses, the molecules will be separated with the help of the electrical and magnetic field. I just want to show you the one flow diagram. See, this is the flow diagram. This is the ionization unit in which the sample will be put, and after the putting the sample will be converted to the ionizing species. And this is the electromagnetic field. Once this ionizing fragments reaches to the analyzer, it will deflect it. This electric field will deflect it, these fragments on the basis of its charge. Okay, so you can see here this is the different color coding: red, green, blue. These red, green, blue, these are the different charge species, and they are separated on the basis of their charge. Okay, so accordingly it will the signal will go to the amplifier and detector. Okay, and the detector will amplify the signal, and the amplified signal will go to the data system. Okay, so this is the complete system. So what happened? The separation of the positively charged fragments formed based on their masses by using electrical magnetic field. See here, this is the mass spectrum. You can see here, this is the mass spectrum of the aspirin. You can see here, along with this long sharp peak, There are other small and other peaks are also available there. These are other peaks are representing the other molecule which is present in the sample. It may be impurities also. And one thing just keep in mind that each peak is a characteristic of the element, right? Each element have their characteristic peak. Okay, no two elements have the same peak. Each element, each molecule will have the characteristic peak. So likewise here, the aspirin have this characteristic peak and the other molecule have their characteristic peak, right? So what will happen? These are the different fragments, and according to their charge, according to their mass, they are deflected with the help of the electrical field. You can see here, this is a vacuum pump. We already told you that all this working is conducted in the high vacuum condition, less than 10 to the power minus 5 torque. Okay, next, MS operation, obtaining a mass spectrum. Yes, resolution. The resolution is a most important thing, because being an analyst, if the resolution is not put in the mass spectrum, we will not able to identify or study the structure of the molecule. So what happened? The width of peak indicates the resolution of MS instrument. I told you the peak should be sharp and you should have the resolution, good resolution with the, it should have the good sharp and the narrow peak, right? The better the resolution or resolving power, the better the instrument and the better the mass accuracy. Okay, the accuracy of our instrument is all depend upon the resolution of or the resolving power of that peak. Because if the instrument do not have the good resolution power, we will, being an analyst, we will not be able to get the accurate to put the accurate result of the sample. So the instrument should have the good resolution of the resolving power, so that we can analyze the sample in a more accurate and a more better way, right? What is resolving power? Resolving power is the power of the instrument to make the difference between the two masses that are separated, right? Two masses that are separated, right? So the instrument should have the power that it can give the difference between the two masses that can be separated. So it should have the resolution also. So what we have learned, the peak should have the peak should be sharp, peak should be narrow, the peak should have the good width, right? And the peak should have the the instrument should have the good resolution power, resolution facility for that spectrum. Next, resolution. Next is the fragmentation. We already took the example of this part. So this is the, I just look at this mass spectrometer. Okay, so there are different parts of mass spectrometer. Number one, the ionization. Next is the analyzer. Next is the detector, and next is the recording system. So there are different types of the this is the instrumentation. Okay, in the next lecture we will learn the instrumentation and the other features of the mass spectrometer. Okay, I hope you understand what we have learned in today's lecture.